So after 2 semesters of electronic lab, I've developed several skills, and I believe those skills would be very helpful in my future career, as they provide me the ability to solve or design circuits. So here are the skills that I have developed. The first one is designing circuits, and then there's understanding the circuits, and the last two is about bug, which the first one is the bug prevention, and the last one is um, being able to debug. Now, the first one is designing circuits. So as the number of components increases, so does the complexity of the circuit. At the beginning of the first semester, the circuits we're dealing with are pretty simple, but at the end of the second semester, things get pretty difficult. So being able to plan the circuits really reduce the difficulty. And without planning or organization, the circuits will be messy. Wires and IC will be all over the place. It would be hard to work on and debug, as it would be near impossible to find the pin to input or output signals. Or sometimes it would just be impossible to trace the circuit when trying to find out bugs. So I usually start designing my circuits by creating common grounds or common inputs, just like in this picture. Sometimes there may not be common input because it depends on the experiment requirements. I will then put in critical components. For examples, op amps are heavily used in these 2 semesters, as I believe it was our main focus. So just like in the picture, I would first place the components on the breadboard. After that, I would start connecting wires between components with color coding. For example, I like to use red for input and power supply, and black for ground and output. And then the next thing is to connect different components. I will always try to find the exact wire length to connect components, as overlength wires sticking out and overlapping one another would make it difficult to trace and debug afterwards. So I would like to keep the whole circuit simple and clean, so that I can work on them afterwards. I've started planning circuits like this from the beginning of the first semester, but my ability have grown, and I think, to my recall, I seldom have problems with my circuits. Almost all of them worked the first time. Even if there's bug, I didn't need to make many modifications to the circuits because it's already very clear and simple. I would just have to replace 1 or 2 wires or so. The next thing is understanding the circuits and bug prevention. Before every experiment, I would first walk through the whole experiment steps in the circuit, trying to understand the whole circuits by tracing the route and the wires. Doing so, I would be able to understand how the logic goes. Also, I would be able to find out some of the tricky parts of the experiment and components or steps I need to pay attention to. Because I've done this walkthrough before the experiment, I would be able to confidently proceed during the experiment. I would usually pay attention to the areas I think would be tricky or may have problems. So like in the picture, these tricky areas are usually the IC or the components, and sometimes the tricky part may be the setting in the input signal. There are, however, some situations where my circuits and settings are correct, but the record results are just not satisfactory. I would then assume there's some malfunctioning components. The first thing I would replace are the wires, because they are used by everyone and some of them are old, so it may cause some bad connections between the function generator and my circuit. If the problem was not solved by then, I would replace critical components in the circuit, such as the IC or the BJT, because they are the most vulnerable components in the circuit. However, I would first test it out before saying that it's malfunctioning or broken. I would do so by inputting a basic signal, for example, a basic sine signal into the components, and to see if the output signal is the way it should be. Because a basic testing or a basic signal would means that it's the simplest and the most basic form. There shouldn't be any problem. But if the output signal is having a weird shape, then the components may be broken and malfunctioning. By doing so, I can determine whether or not the component is working properly. If it's not working properly, then I would just replace it with working components, and usually the bug would be solved. So this is my semester report, and I've learned a lot in these 2 semesters. Thank you.